our pre-security upgraded and it's got a new rooms like three modules are upgraded to pre-security. Now we are in computer fundamentals inside a computer system. Let's go. What it is? Introduction. It is welcome to the first room of computer fundamental module. Before we can talk about security, we need to first understand what we are securing. Consider the following analogy. Before protecting a castle, we need to know the layout of the castle. Before the treasure room, the food storage, and the commander's quarters are, we need to know who enters and how they enter the castle. Also important is who can enter this room and take or put treasure or food. For example, the bottom line is, uh, I'm very bad at reading, right? We need to know who enters and how they enter the castle. Also important, who can enter these rooms and take or put treasures or a food, for example. The bottom line is, trying to defend what you don't understand is like defending a castle you have never seen. In this room, we will explore our castle. We will cover what a computer is, its building blocks, and how they are connected. After completing the room, you will have a general idea of how the components of a computer system interact with each other to provide services to its user. Don't ever too much technical jargon or depth. We will take this nice and easy and focus on the fundamentals. Learning objective. After completing this room, you will able to recognize and understand the function of various computing components. Prerequisites motivated to step into digital world of computing. Let's get started, guys. Oh, here it is something. Task is done. Let's see. Nearly every computer system that you can think of includes, in one way or another, the same building blocks. Each part has its own job, and together they make a computer work. Let's have a look at each of these building blocks. RAM, short-term memory, heart of PSU, heart and the lungs, motherboard, the skeleton and the nerves, CPU, the brain, GPU, visual cortex, hard disk, and this is SSD. Hmm. Uh, Throughout this task, we will use very relatable analogy. The human body, the image above shows the different PC components and is human counterpart. Let's learn about how this each component. This is a motherboard. This is RAM. This is PSU. It's like a fan, fan. It cools the computer. This is GPU. This is a graphic card. You can say this is CPU. This is memory. Click the component to discover what it does. Complete all aids to unlock the section. What component? Computer components. Oh, I can here choose it. What role does the motherboard play in the computer? It processes all the calculation and infrastructure. It connects and allows communication between all components. It's stored and it connects all these parts in this one thing. The ports all if we let me tell you this. We connect keyboard, right? Keyboard that is connected to this motherboard. If motherboard doesn't have a port to plug in the keyboard, it will not connect. Yeah, See, the motherboard is like, oh, here it is. Now I don't need to explain it is here. The motherboard is like our body, skeleton, and nervous system. It holds all the different components in place and connects them. On a typical desktop motherboard, you will see different connectors that house all your components. CPU sockets, RAM slots, expansion slots, and various ports. Every other component is plugged into or connects through the motherboard. The image below shows a typical desktop motherboard. I am not very good at this, but you can see. Let's see, CPU. Stores files and program execute instruction and perform calculation. Kernels, CPU, it is this execute. It's like a brain, but let's see. The CPU, Central Processing Unit, often called the processor, it is comparable to a part of our brain. Just like our brain continuously executes instructions, add numbers, pour milk in a bowl, or so on. A CPU does the same for the computer. Modern CPUs have multiple cores that handles instruction in parallel. The CPU connects to the motherboard via the CPU socket. The image below shows a typical CPU for a desktop. Let's see, complete RAM. Stores data temporarily while the computer is running, saves files permanently like photos and documents, display images on the monitor. RAM stores data temporarily. Is it that right? Yes. RAM, random access memory, is comparable to our brain's short-term or working memory. When working on a task, we keep relevant information in mind temporarily. RAM does the same. It holds the data that CPU needs quick access to. RAM is volatile when power is lost. All the contents are done. Modern RAM modules use technologies like DDR5, DDR6 for increased speed and performance. The image below shows a RAM module for the desktop SSD to process the instruction faster than CPU, to hold data temporarily while programs run, to save data permanently when powered off. That is correct. SSD and SDD are storage device comparable to our long-term memory. Just like phone memories are remembered permanently, data is saved long-term on storage device. SSDs use older technologies with their moving parts, limiting performance. SSDs have no moving parts and use memory chips, allowing much faster speeds. HDDs remain popular for their large capacity at low cost. Storage connects via SATA cable or a PCI Express slot. The image below shows HDD on left hand side and SSD on the right hand side. Network adapter. What does stores more files in the cloud, communicate with other computers and networks, run program faster. Let's see. Just like we use our local cords to communicate with our environment, a network adapter lets computer communicate with other systems. Network adapter come in a wireless and wired variant. Often they are embedded in motherboard, but they can also be added as an expansion card. Network cards typically connect via PCI Express ports. The image below shows a plug-in network card typically used in desktop. Power supply is supply to cool down the computer component, to supply electrical power to all components, to boost the computer processing speed. B. Let's see. Every system needs power just as our heart pumps blood to our organs. The PSU supplies energy to all system components. The PSU is essential and require careful consideration. Oh, it's not a fan though. I thought like it's a fan to cool down, but it's a power. See, in my laptop it's a brick, but it's as a fan also. I thought it's a fan. Sorry about earlier confusion. The components need more power than the PSU can provide. The system will fail. PSU take power from outlet and distributes it via connectors like a main motherboard connector or Molex connector. The image below shows PSU used in desktop. Graphic card. What does graphic card primarily handle? Processing and outputting visual information this display, connecting the internet fast, storing game files and video files. No, it is FPS. Uh, Graphic card is comparable to visual cortex of our brain. Our eyes pick up the information and visual cortex processes it into an image. Similarly, graphic card receives information from the operating system and program, then output the processed visual data monitor. Graphic card connects to PCI Express slot on the motherboard. The image below shows a modern day graphic card used in desktop and input output device used for gaming and entertainment to send data and receive data from computer. It is this. Just like we have sensors to obtain information for our brain, the process and then the computer have input and output devices. Input devices include keyboard, microphone, and scanner. Output device include monitor, printer, speaker. Common connector for these include USB, HDMI, and DisplayPort. The image below shows a few basic input-output devices: keyboard, mouse, headphone, monitor. What the hell? This is so damn big. Motherboard inspection. Start the motherboard to learn where each component connects and over the highlighted areas to see details. Back to component. Let's see. These are the slots, right? Uh, Rare input output ports. Connects the computer, mice, monitor, and USB drives contain CSP network and video ports used to connect external devices. This is CPU socket. Alright, what is this big chunk? This is PSC Express 16 slot. Connects a graphic card. Long reinforcement slot is typically used for the graphic card, but can also host other. What is this? PCI Express 16 slot connect graphic card. This one is graphic card connectors. All right. This is the RAM. All right. Long vertical slots where memory modules are installed. What is this pin? 24 pin ATX power connector connects to power. Oh, this is power supply. Main. What is this? SATA points. SATA ports. Thin L-shaped data connector used to attach SSDs and hard. Dun. That's it. There is nothing more. Okay. Oh, ho. First we will add the RAM. Drop your RAM, CPU, graphic card, network adapter. Tennis, storage is in here. Input output is here. This is we can add anywhere. It is one also, this one also. All right. Verify. Nice. This is they are adding extra, right? This is inbuilt. You can make it extra too. Let's see. This one is done. This room is very fun. I did not add that when I am learning this one, the security part. I learned there many things, right? I didn't know how it's looked properly. I opened species, but I didn't know what happens when you press the start button. Now that the core components are installed in the computer system, it is time to boot up the system. We can compare this to how we wake up in the morning and do quick check to see if everything is working. Only when everything goes we get up and start our day. The image below shows the steps computer system goes through before it shows you a working interface. Press the power button. Firmware starts. Post. Select boot device. Start bootloader. When we press the power button, our simple firmware start. Continuing our order from step 1. Once the body has started up, our core components are up and running, but our brain is not yet conscious like our bodies. Computer system contains firmware that allows all its components to start up. The central system that manages this is called a unified extensible firmware interface. We will often see the term BIOS mentioned instead of UEFI. BIOS does the same as UEFI but has mainly been replaced by UEFI. Power on self test. Post power on self test. Now that our body is up and running, it is time to test if everything is functioning as it should. If something isn't, there will be some alarm signals. One of the routine that UEFI loads in the power on self test, which tests if every required component is present, configured correctly, and functioning. Therefore, select a boot device. Once our body is up and running, configured correctly, and fully functional, our system searches for a location for our boot up routine to start our consciousness. In our computer system, UEFI holds an ordered list which prioritize on which device to look first for the boot up routine from the operating system. Initial bootloader. Now that our system knows the part of our brain where our consciousness is located, it initiates the load routine. To start it, our computer system follows a similar process on the selected boot device. The bootloader is initiated. The bootloader transfers the operating system from the selected boot devices to random access memory. Once the OS is transferred, the UEFC gives control over the different components of the OS. Now that we know how the computer system works, let's have a little exercise. Let's see. Learn drag and drop challenge. Press the button. You press the button, sending the signal to PSU. Let's system begins powering up. What happens when the operating system start loading? The PSU start delivering power to components. Click answer. Alright. Uh, Firmware starts. Is your order bias? I never saw this, man. My laptop has this. I recently bought in like 2025. Firmware initialize and coordinates components. It's the first software that runs. What happens next? What is UEFI's role in the boot progress? It runs your application, it initializes and coordinates the RM. It connects the internet. Let's go. Post. You have to run post to check the required hardware to present, configure, and add function. What happens next? What does post check for? Whether your program are up to date, whether required hardware is present and working, whether you are connected to internet. Select a boot of device, typically SSD or S. How does UFC know which device to boot from? It randomly selects the storage device. It for the configure boot by at least it always uh, initial bootloader. The bootloader loads the operating system into RAM. Then UEFI adds control to the OS, completing the boot sequence. What does the bootloader do? Shuts down the computer safely, loads the computer system into RAM. Test the keyboard. Yes, Sabas. Drag and drop challenge. First press the power button. Uh, uh, Start correct. Oh, sorry. Let's see. Copy. Let's see the conclusion. We have covered the core components of a computer system and how it boots up. At the moment, you won't realize this, but further on, when learning cybersecurity concept, you will often need to recall the functions of each of these core components and how they interact with each other. The progress is very important concept later on, as it is sometimes targeted by hackers. Now that we know the insides of a computer, the next step is to see how different combinations and specialization of these components leads to diverse types of computer systems. Continue to next room the computer types coming soon. I am ready to discover the different types now.